Okay, yep. All right, so we're now going to go ahead and look at question 3 from our homework. Do what? 9? Sure, yep. 3 and 9. We'll start with 3, and we'll look at 9, and we can add more to the list as well. On these, another thing that you need to notice is this is going to kind of tell you what type of answer you're going to have usually. Does this question say anything at all about rounding? No. Okay. That tells you that it's probably going to factor and you're going to get whole numbers. Versus things like this one. Let's see. Like this one here. Okay, talks about the interest rate. That was probably going to be a rounding one. Some of these, though, okay, especially like number 9. We're going to work out number 9 in a minute. But you know number 9 is going to either be a square root property question or a quadratic, because notice on 9, what does it say? On question 9, it says round to the nearest tenth. If it says round, it is probably either going to be solved using the square root property or the quadratic formula. It is not going to factor. If it doesn't say anything about rounding, it should factor out. So that's how you can kind of tell what you're working with. Anytime it says round, probably square root property or quadratic formula. Otherwise, you can use the 0 factor. So that's something that you can look at and see. Question 10, same way. What does it say? Round to the nearest tenth of an inch. Okay. Question 10 is going to be using the square root property. I know I set that one up last time. That one is direct use of the square root property. And it says round. Now, question 3, does it say anything at all about rounding? No. Okay. No, it does not. So does it say anything about rounding at all, does it? Right? So we should be able to probably use 0 factor. Next, we're going to read the question, and we're going to see what formulas we need and where to begin. So the height of a box is 6 inches. Its length is 6 inches more than its width. Find the length if the volume is 162. So the first thing we need is we need to see what kind of figure that we're looking at. So we are looking at here a rectangular solid. Okay, it's a cube, or not a cube, it's a box basically, right? Okay, so that box is also called a rectangular solid. So rectangular solid is 3 dimensions. And it looks like this. Now, what do we know? Okay, this is going to have a length, a width, and a height. And it says on question 3, the height of this box is 6 inches. So we'll label that H as 6. Okay, easy enough there. What do we know about the width? It says the length is 6 inches more than the width. So my length, we'll call that L, 6 inches more than the width. So that's going to be X plus 6. And do we know the width of this box? Nope. So that's going to be X. Now, you can either memorize the formula or you can go back and look it up. A box looks like the rectangular solid, doesn't it? And what's the volume here of a rectangular solid? It's very easy. You just multiply all the parts together. Right? Length times width times height. So let's now build our equation. So what do we know here? We know our volume is given in this question, and that volume is 162. And the volume is length times the width times the height. So let's go ahead now, write our equation up. And that means we're going to multiply all these together. It doesn't matter the order. I'm just going to multiply them all together. And that's going to give me my 162. So they're all multiplied together. So we've got 6 for the height. Width is an x there. And the length is x plus 6. Is everyone okay with how I got that equation? This one is really not that difficult to get the equation on. How do we solve this? Well, first thing, we notice that we've got to distribute. And when we distribute that 6x through, it now becomes a quadratic. So that gives me 6x squared plus 36x equals 162. Remember, there are two types of equations, linear and nonlinear. Nonlinear means it has a square or a cube or something else in it. And nonlinear equations, what do? We have to set them equal to what? 0, right? And we're either going to factor or we're going to use the quadratic formula. So let's go ahead now and set this equal to 0. So move that 162 over. And these questions are difficult because they're hard to set up and they're also sometimes hard to solve as well. So it's a twofold. Sometimes they're not easy to set up and they're also sometimes not easy to solve. How would we work with this one? Well, before we do anything else, always look at the numbers. What do we have? We have a 6, 36, and a 162. We need to get these numbers down as small as possible. So what number's in front? We've got a 6 in front. Okay, we know 6 goes into 36, right? Does 6 go into that 162? I think it will, won't it? Because 162 divided by 6 is what? 27. So the first thing I would do before I do anything else is divide it all by 6. That makes the numbers a lot easier. So now we have something that should factor. So now we have x squared. We have a plus 6x, right? And then we have a minus 27. And that equals now what? 0. Now we don't have to factor by grouping. We can jump directly to our factors. So first times the last. First times the last, that's a negative 27. And it's a negative 27. So what do we know about the signs? Are they different or are they the same? Okay, they're going to be different, aren't they? Right? Why is it going to have different signs? Because it's negative. And how can you get two numbers to multiply together to give you a negative? One positive, one negative. What's the sign in the middle? Positive. What two numbers would work here? Can anyone tell me? Yep. We'll use a positive 9 and a negative 3. Do we have to do factor by grouping? No, because it's a 1 here. If it would have been a 6, we would have to do more work. This one is a 1 here in front, so we can now factor it out. And that is x plus 9, x minus 3. So be careful with your answers. We've got x plus 9 equals 0. We'll move it over. So one possible solution is negative 9. What about the other one? X minus 3 equals 0. So x equals now what? 3. Only one of these is a legitimate answer. So which one can I eliminate and why? Negative 9. Why can I eliminate the negative 9? Because can you have a negative length or width? No. Now let's make sure we get the actual answer. It says find the length. So we want to make sure we answer the question and we want the length. Is this 3? Is that the length? Yes or no? No. What is this 3? Going back to our picture, that 3 is the width. We want the length. So we need to find the length. So the length is your L, and that's x plus 6 here. And what do we know that the x is? X is 3. So that's 3 plus 6. That makes it then a 9. Now, there's no units, but 9 would be the answer there. Does it make sense how I set it up now and how to solve it? Where students struggle at is it's usually at the very beginning here. If you don't divide out by that 6, those numbers are going to be very difficult to work through. But once I divided by the 6, then they became easy. So always, always check to make sure there's no number in common. If there's a number in common, it's going to make it a lot easier to deal with. We want to get those numbers as small as possible. And in that case, that 6 came through, and we didn't even have to do grouping. Now, you could have done the quadratic formula, and you would still get the same answer. If you want to use a quadratic formula, you can. It's a little more work, but you'll get the same answer. So is everyone all right with that one now? Question number 9. Sure. Yep, 9, because there's no units on there, is there? Right, if we go back up and look, it doesn't give us feet or anything, does it? Right? If this would have been a volume of 162, let's say, cubic centimeters, then our length would be in centimeters. But this one doesn't have any units, so we don't have to label it. Do what now? Oh, it does say inches, doesn't it? Yeah. Sorry about that. Should be in inches. My mistake. I didn't see it because they didn't label that volume. So that volume should have been in cubic inches. Right? They didn't label it, but it should actually be in cubic inches. So yeah, when you label it, I should have been more careful. It's going to be 9 inches. If you forget to label, it's not the end of the world. I don't usually take off points for you not labeling. I do correct you on it, but I don't take off points. Question number 9. This one, I already know, says round. So that means we're going to have to either use the quadratic formula or the square root property. It's not going to factor. So a ball is thrown downward from a window in a tall building, and its position at time t is given by this equation, where s is in terms of feet. And it says how long, 1 to the nearest 10th, will it take the ball to fall 264 feet. So all you need to do is take this 264, and that is your s there. But then we still have to solve it. So if we replace it, we've got s equals, here's our original equation, okay, s equals 16 t squared plus 32t. By the way, that 16, that's the effects of gravity. If you take a physical science course or a physics class, you would talk more about how we came up with this equation, but in this course, we just use the equation. And we want this height, s, to be 264. So all we need to do is replace that s with the 264. Now, how are we going to solve it? Well, we already know it says round. This is not the square root property, is it? Because we can't just take a square root and solve it. We're going to have to set it to 0, apply the quadratic formula. So let's do that first. Take your time with these. So move that 264 over. And then we'll see what we've got here. Okay, now, what do we need to do first? Before we do any other work, we need to see if we can get these numbers to be smaller. So we've got a 16. 16, I think, will go into that 32, won't it? Right? Just 32. You can always check with the calculator. Divided by that 16 is 2. Does it go into that 264? Nope, it doesn't, does it? What about 8? Does 8 go into that 264? We need to get the numbers down as small as possible. 8 does, right? 16 is divisible by 8 2 times. And 32 divided by 8 is what? 4. So what are we going to do? We're going to divide everything now by what? 8. Why are we doing that? To make our numbers smaller. Now we have 2t squared. 32 divided by 8, that's a 4t. And then we've got 264 divided by that 8. And that then comes out to be 33. Anytime it says round, we're not even going to try to zero factor because it's probably not going to factor. If it says round, that's a general indication that we're going to have to use that quadratic formula. No sense in even trying to zero factor because it's probably not going to work. So let's find our pieces. In this case, my A is 2, B is 4, C is negative 33. So what's my formula? In this case, we have a t, but we can use the x. It's the same thing. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And we're now going to plug in our pieces. So now we've got negative b, so that's a minus 4. And then we've got plus or minus the square root of 4 squared minus 4 times 2 times that minus 33 all over 2 times 2. Now the good thing about this one is it says round, so we are not going to have to break these roots down. We're going to be using our calculator. If it says round, then we don't have to worry about exact roots. We use our calculator. We always take it out a little bit further than what we need. That way we can round at the end. It says nearest tenths, so we'll take it out 3 places on our square root. That way when we round and get our final answer, we can get it to the nearest tenth. So always take out a little more than what you really need. So let's clean this up a bit and then work out our discriminant. So now we have minus 4, and we've got a plus or minus our square root here, and 2 times 2, that makes it a 4. What about my discriminant? My discriminant, and this is where students are most likely to make a mistake, my discriminant is 4 squared minus 4 times 2 times a minus 33. Well, 4 squared is 16. And let's talk about our signs. How many negatives do we have here? 2. And a negative times a negative makes then this sign what? Positive, doesn't it? So I always get my sign first. 2 negatives, even number of negatives makes it positive. Now we just multiply. So 4 times 2 times 33. Well, that's a 264. And we'll go ahead and add our 16 to that. And that gives you a 280. Now, the good thing about this one is this is an application, and we're not going to have to try to factor down 280. It says round, so we're not going to try to break it up. We're going to use our calculator. So let's go ahead and use our calculator, and let's figure out what the square root of 280 is. And we'll take it out to 3 places. So second, square root, because on these, you can, if it says round, you can use your calculator. 280, and And that square root comes out to be 16 point, we'll say 733. Close enough. Is everyone okay with that so far? Right. Now, I can get my two solutions. What are my two possible solutions going to look like? Well, one of them is going to be minus 4 plus that 16.733 over 4. And the other one is minus 4 minus 16.733 over 4. We don't have to work both of these out. We are looking for time. Can time be negative? Can time be a negative number? No. This one's going to come out to be positive, isn't it? Because minus 4 plus 16, well, that's a positive. If I just look at whole numbers, minus 4 plus 16 is 12. Okay, so positive 12. In a way, I mean, we've got the decimal, but this one's going to be positive. What about this one? Minus 4 minus 16, if I look at it like that, that's minus 20. It's negative. Can time be negative? No. So I don't have to worry about that one because that one's already negative. And we know time cannot be negative. So all we have left is this one. So let's go ahead and work this one out. So we've got minus 4. I'll put it up here so we can see it. Plus 16.733. And that gives me a 12.733 over 4. And then we'll divide that by our 4. And how far do we need to round here? What does it say? It says round to the nearest what? 10th. So I'm going to round this to the nearest 10th. So that's going to be 3.2 seconds. And that makes sense because that's a legitimate time. If you threw something up in the air, it takes 3.2 seconds for it to come back down. Is everyone okay with how I did that? So on these, you can use your calculator. You don't have to break up that 280. You don't have to break up the 280 at all. Use the calculator. Take it out a little bit further. So we want a nearest 10th. That's one place. I'm going to take it out 3. That way we can round and get the correct answer. So is everyone all right with how I worked out that one? Take your time on these, especially with the signs. Where are students most likely to make a mistake? In the discriminant. Where is it going to be at? Right here. Because I guarantee you that someone's going to say that's a minus 263. And it's not, because a negative and a negative makes it a what? Positive. Do we need to look at any others out of 1, 5? Are there some more that you would like me to go over with you? Any others? Is that going to take care of most of these? We can look at some more of these on Tuesday if we need to as well. Because if you haven't worked through all these yet, try them again. And if you have more questions, we can look at some of those on Tuesday. Well, if we don't have any others, then we'll go ahead and start the next section. And the next section is other types of equations, and that's 1.6. So we're going to look today at 1.6. And there are several different types of equations. We're going to look at, in this section, square roots, how to handle those. So equations that have square roots. We're going to look at equations that require substitution. And then we're also going to be looking at equations that have fractions in them. And we're going to start off by looking at the fractions. We're going to start off with rational equations. And just so we know the terminology, when I say rational equations, we're talking about fractions. And the first step is going to be find the domain. So on all of these, the first thing that we always do is find the domain. And when I talk about the domain is your possible values of x. And that means no division by 0. So we cannot have division by 0 because that is undefined and we can't have that. So the first thing that we always do with these rational equations, the fractions, is we find out the values of the domain. What numbers can work and what numbers can't work. And how we do that is we set the denominator to 0. And then you solve. And this is going to go with homework 1.6, questions 1 and 2. So this is going to be like questions 1 and 2 for your homework. So we're going to be looking at finding the numbers that won't work. Find the values of x that are not part of the domain. And again, we do that by setting the denominator to 0. So we'll do a couple of these. And I'll use the same basic directions here. Find the values that cannot be solutions, or find the numbers that are not in the domain. So that's what we're going to be doing. We're going to be finding the numbers that are not in the domain. We're not going to be solving this one. We're just going to be finding the numbers that are not in the domain. Now, when we find the numbers that are not in the domain, what we are looking at is division by 0. So what we do is we set each denominator to 0. And you may have more than one. Some of these you may have to factor. So what are my two denominators here? Well, the first one is x minus 7. So I'm going to say x minus 7 equals 0. And when I solve it, we get x equals 7. What's my other one? Okay, that goes with this one. This one says x equals what? 0. These are the two numbers that are not in the domain. Now, why are these two numbers not in the domain? Well, 7 is not in the domain because if I plug in 7, what does that give me? That gives me 7 minus 7, which is what down below? 0. Can you ever take a number and divide it by 0? No. So that's why 7 doesn't work. And why does x equals 0 not work? Because if I plug in a 0 here, I get 4 divided by 0. Can you take 4 and divide it by 0? No. So all we did was we set our denominators to 0 and we solved. Let's do another one. Same directions. Find the numbers that are not in the domain. How about I give you about 3x squared minus 9 over, let's say, x squared minus 16 plus 5 over x minus 9. So this was just an expression, and these can be either expressions or equations, and all we're doing is we're finding the values of x that are not in the domain. Well, what do we have for our denominators? We've got these two. This one is going to give us 3 solutions. So our first one is x squared minus 16 equals 0. We can either factor this one as a difference of squares, or we can just use our square root property. So add that 16 over, and now we've got x squared equals 16. And how do we now get rid of the square? What do we use? Okay, someone said it. Square what? Root. And whenever you take a square root, what else do we have to add on? Plus or minus, right? Okay, and what's the square root of 16? Square root of 16 is 4. So there's 2 of them there. What about the other one? X minus 9 equals 0. So what other number is not in the domain? None. Okay, so what's going to be our answer? What numbers are not in the domain? These numbers are not in the domain. 4, -4, and 9. So those numbers are not in the domain. So is everyone all right with how I figured out what numbers are not in the domain? Do we care at all about the numerator? Did I even concern myself at all about this 3x squared minus 9? No. Okay? Because we're not solving on these first 2 questions. We are only finding the numbers that won't work. These numbers won't work. Now, why is that important? That's important because when we solve them next, we have to make sure that what answer or answers we get actually work. So now we're going to learn how to actually solve these rational equations. And so there is a step-by-step set of directions that we follow. The first thing, these are our fractions. So the first thing we do is we find the numbers not in the domain. Step number 2 is we clear the fractions. Step number 3 is we just simply solve it. Okay, so solve the equation. And then step number 4 is make sure all answers are in the domain. So we're going to make sure the answers are not in step 1. So this is our procedure. Find the numbers that don't work, clear the fractions, solve it, and make sure our answers are not in this step. Because if they are, then it has no solution. If they all don't work, well, you might be able to just have 1 instead of the 2. So I'm now going to pick these from our textbook to look at. And when we solve these rational equations, there's some that are easy and there's some that are quite a bit more difficult. We're going to start off with an easier one, and then we'll move on to the more difficult ones. Some of these may require you to factor. You shouldn't have to use the quadratic formula. These should all be either factorable or using the square root property. So let me pick a couple of these. out of our textbook to look at. And we're going to start off with an easier one, and then we're going to look at a more difficult. So how about we look on page 164, how about we look at question 18? So we're going to be looking here on page 164, and we're going to look at question 18. Now we're going to follow this step-by-step procedure here. 18 is 4x plus 3 over 4 minus 2x over x plus 1 equals x. And the directions here are going to be solve. Now, we're going to go through our step-by-step procedure. So what's the first thing we look at? We need to find what number or numbers are not in the domain. And so when we look at these domains, we only need to worry about the ones with the x in them. So this first one, down below, there's no x with that 4 down below, is there? Right? So we don't have to worry about this one, because there's no way that we can get division by 0. But this one we can. So what number is not going to be in the domain? Well, once you do a few of these, you won't have to write them out, but until we get to that point, we'll write it out. So we've got x plus 1 equals 0. So what number is not in that domain? -1. Because -1 would make this what? 0, and we can't do that. There's no x here, so that one's okay. Now we proceed to step 2. And what was step 2? Clear fractions. How do we clear the fractions? Well, we look at it in one big problem, and we figure out what we need to use all at once. So we're going to look at this, and we're going to look at each piece holistically and figure out what we need to get rid of all the fractions. So the first one, what's down below? 4. So I'm going to need a 4. And what about the second fraction? It has an x plus 1. So I'm going to have to use an x plus 1. Let me write it up a little bit neater here because I know it's kind of hard to see. So I'm going to have to multiply this by 4 times that x plus 1. Now, why do I need the 4? Okay, the 4 and 4 will cancel here. The x plus 1 and the x plus 1 cancel there. That's going to get rid of all of my fractions. And that's what I want. So we go through one at a time. So on my first one, what's going to happen here? 4 and the 4, they do what? Cancel out. What am I left with? I am left with 4x plus 3. And what is it going to get multiplied by? X plus 1, right? Because that canceled, but nothing canceled with the x plus 1. Then we do the next piece. Well, it's a minus 2x. And what happens with it? In this case, the x plus 1's cancel, don't they? So what do we still have left that's not been canceled? That 4. So that's going to be a minus 2x times 4. What about the other side? Well, nothing cancels at all, so I'm just going to put the x with it, and that's going to be 4x, so I'll just put the x with the 4 in front, times x plus 1. Now we have something that we can work with. We're going to have to FOIL, and a lot of these are going to require quite a bit of algebra, quite a few steps here. So these are not something that you can just do in a couple of steps. They require a careful thought out, FOILing, maybe factoring, a combining like terms. So I'm going to have to clean this up a bit. So I'm going to begin by foiling this. So let's FOIL this out. We've got 4x plus 3, and we're going to FOIL that with an x plus 1. So we'll FOIL, and we'll just slowly break this down. Remember how to FOIL. I know it might have been a bit since you had to FOIL. Hopefully you know how to FOIL. We got a 4x times an x. That makes it a 4x squared. We've got a 4x times 1. That makes it a 4x. And we've got a 3x here in the middle. And 3 times 1, well, that is a 3. Combine like terms here. And that is now 4x squared plus 7x plus 3. What about this piece? What am I going to do with this? Well, this is just multiplication. And 2 times 4 is an 8. And that negative just comes down as a negative 8x there. On the right-hand side, what are we going to do? Well, we're going to distribute that 4x through. And that's going to leave you with a 4x squared plus 4x. Now, I know these take a little bit of time to work through, but we're almost done. We've got a couple more steps left. Let's go ahead and clean up the left-hand side. What can I do on the left-hand side? Well, that's 7x and that negative 8x, those can go together. Now we've got something that we can work with. So now we have a 4x squared. We've got a minus x plus 3, and it equals a 4x squared plus 4x. This is going to be linear because what's going to happen to that 4x squared when I move it over? When I move that 4x over, we're in luck because it's going to cancel out with the other one, right? And it's going to leave something that is linear. So we're not going to have to factor because when we move this 4x squared over, it cancels with the other side. And that leaves you now with a minus x plus 3 equals 4x. And we know how to solve this because this is actually really easy to solve. Okay, how will we solve it? We don't have to factor it anymore. We just simply move things around. So all we have to do, don't try to factor it, you just move it over. Move that x over. Rewrite it. So that makes it 5x now equals 3. We'll divide by our 5. So what's our possible solution? Our possible solution is 3/5. Now, how do we know that this is an actual solution? Well, what number can it not be? It cannot be what number? It cannot be -1. Is this number -1? No. So then it works. If this would have been -1, it would have no solution. So we need 0 with the slash with the empty set. So let's try another one. That was one of the easier ones. Believe it or not, let's now look at 21. And 21 is going to require us to factor a little bit. Same directions, we're going to be trying to solve here. And when we look at these, we always want to try to factor. Before I start finding the domain, if you see something that'll factor, you want to factor. What do we know about x squared minus 9? This is a difference of what? Does anyone remember? Difference of squares, right? And how do we factor a difference of squares? Plus and minus. And how do we know that it's a difference of squares? Well, is 9 a perfect square? Yes. 9 is a perfect square of what? 3. So the first thing I would do is I'm just going to rewrite this as a minus 2 over x minus 3 plus 3 over x plus 3 equals minus 12 over x plus 3 x minus 3. So I just factored it. And now we can see what numbers are not in the domain. So what numbers are not going to be in the domain? What do we have to worry about here? We've got denominators here. What's our first one? First denominator is x minus 3 equals 0. So what number's not going to work? 3. What also number's not going to work? Well, the next one is x plus 3 equals 0. So another number that doesn't work is what? Minus 3, right? So 3 and minus 3 won't work because those are going to give you division by 0. Now, how do we clear the fractions? Well, we need to get rid of all the fractions at once. So we're going to multiply, and whatever we multiply through, it has to clear all the fractions out. So we look at them individually, all at once. So x minus 3 is down below, so we need an x minus 3, and an x plus 3 will clear the second one. X plus 3 and minus 3 cancels here. Okay, so make sure everything is represented. The x minus 3's cancel, the x plus 3's cancels, and that cancels with that. So now we're going to distribute through. X minus 3 and x minus 3, those can cancel. And so that leaves you with a minus 2 times the x plus 3, right? Because that cancels with that. And that leaves you with that. What about the next one? Well, we've got the 3, and the x plus 3's cancel now, don't they? So it's going to be a 3 times what? Minus 3. And what about the right-hand side? Well, it's nice and easy because all of that cancels with all of that. So the right-hand side is simply a negative 12. Now let's go ahead and clean it up and see what we get for our solution. Careful with your negative 2. We've got to distribute that through. Same thing with our 3. So that's a minus 2x, a minus 6, plus 3x. 3 times a negative 3 is a negative 9. And that equals our negative 12. Combine like terms. So that leaves you with an x when we combine those together. Minus 6 and minus 9 makes it a minus 15. Now we can solve it by adding our 15 to each side. And we now have x equals what? X equals 3. What's the problem? Why is x equals 3 not going to be my answer? Because it's not in the domain, right? So this 3 is right here. So that can't work. So my answer would be the empty or the null set. Are we finished? Okay, yep, I'll stay with you. Thank you, Gabby. Okay. So let's now talk about another one. Does everyone see why this has no solution, right? Because it doesn't work. Now, if this would have been, let's say we would have solved it and we've got 3 and a 10, then the 3 wouldn't work, but the 10 would work. So you can have two solutions, and maybe only one of them works, or maybe they both work. So let's try one more, and then we'll move on to another type of question. Let's look at 30, and how we would handle clearing out the fractions on 30. So question 30, 7 over x squared plus 19 over x equals 6. So what number is not in the domain? Can anyone tell me what they think won't work? What number is not going to work here? Just look at these. 0, okay? X squared is the same thing, because x squared equals 0 still means 0 is not going to work. So the number that is not in the domain is 0, right? Because the only thing down below is an x and an x squared. So 0 is not going to work. It's not in the domain. How do we clear our fractions? I think we did one of these back in 1-4. How do we clear out these fractions? Well, we look at what's down below. And what's down below? X and an x squared. We want the highest one, the largest power. What's the largest power? X squared. So to clear out all of my fractions, I'm going to have to multiply this by x squared. And when I multiply that by an x squared, it's going to take care of the x, and it's also going to take care of the x squared below. So we're going to distribute this through, and it's going to all cancel out. So let's see what we've got. When we distribute through, the x squared and the x squareds cancel. That leaves you with the 7. The x squared and an x cancels. That leaves you with a 19x. And then we've got x squared, nothing to cancel. So that leaves you then with a 6x squared. Now we should know what to do. So what are we going to have to do? Where would I begin? What would I do? If I want to start solving this equation right here, what would I need to do? Set it to 0. That's what we're going to do first. So set this to 0. And now we've got 6x squared minus 19x minus 7 equals 0. We should not have to use the quadratic formula. Everything should factor out nicely. You should not have to apply the quadratic formula at all. You can, but it's going to be more work. So this one is not going to factor. Or, sorry, not going to be using the quadratic formula. It will factor. So first off, we have a 6, a 19, and a 7. Is there any number that's in common? Nope, nothing's in common. So nothing comes out. Always check that first. That's going to be the first thing you do. Could have been a 2, could have been a 3 in common. In this case, there was nothing. So nothing's in common. So what do? We take the first number times the last number. First number times the last number. Well, that's going to be a minus 42, isn't it? Okay, and let's review how to factor again. If it's a minus 42, what do we know about our signs? Are they different or are they the same? Different signs or the same signs? Which one? Different, okay? Why are they going to be different? Because this is what? Negative. Sign in the middle is negative, so my signs are negative and positive. Now we need two numbers again, multiply together to give you 42. Subtract from each other to give you 19. 42 is an even number. If it's an even number, always start with 2. So let's see how close 2 is. So 42, divide that by 2. 2 and 21. Well, that was nice because 2 and 21, did those subtract together to give you 19? Yep. And these will be easy to factor for the most part. So we need a minus 21, and we need a positive 2. Can we jump to our factors? No. We're going to have to split up the middle and use factor by grouping. Why? Because this has a 6 in front. So this 19, we have to split it up. So now we've got 6x squared. We've got a minus 21x. We've got a positive 2x and a minus 7. So we split up our middle, and now we factor. So what can come out of the first two pieces here? Okay, can anyone tell me what will come out? 3x comes out, and that leaves you now with a 3x minus 7, looks like. Oh, sorry, 2x minus 7, my mistake. It should be a 2x there. And that should line up with the second piece, two parts here. And what can I factor into there? Well, nothing, but you can always take out a 1, and that's going to then leave you with a 2x minus 7 as well. Our groupings should be the same. If the groupings are not the same, if the parentheses are different, you made a mistake. These are the same, aren't they? So we know that we're on the right track, and that 2x minus 7 can come out, gone and gone, and what's left over? What's left over is 3x plus 1. We're almost done here. So what are we going to do next? It's factored. We solve it. We're going to go ahead now and get our two solutions here. And we have a 2x minus 7 equals 0. So 2x equals 7. Divide by your 2. So one solution is x equals 7 over 2. Now, is that going to work? Yes or no? Is that going to be a legitimate answer? Yes. Why is it going to be a legitimate answer? What number won't work? 0. Is that 0? No. So it works. Now there's another one. This one has two solutions. What's the other one going to be? And always write it out so you don't make mistakes with the signs. So that is 3x plus 1 equals 0. Move the 1 over. So 3x equals now negative 1. We'll divide by our 3. And now we've got x equals a negative 1/3. Does that one work as well? It does. So we have, in this case, two solutions, and they both work. Now, like I've said before, 1.5 and 1.6 are the most difficult sections in this course. 1.5 is the applications, and they take a long time to work through. 1.6 is difficult because of all the different types of equations. So we learned how to solve these rational equations. Now we're going to talk about square roots and how we handle square root equations. So we'll work through a couple of these. We may not be able to get through all of them today, but we'll be able to get through a lot of 1/6. So we won't be able to get it all done today, but we'll be able to get through a lot of them. So let's now talk about square roots. Now, in 1.4, how did we get rid of a square? What did we use? When we had a square, we got rid of a square by using a square root, right? So if we have a square root, how do you think we're going to get rid of a square root? Square. Okay? They're inverses. They undo each other, like addition and subtraction. So whenever we have a square root, we use a square to get rid of it. And this also has a step-by-step procedure. So step number 1 is you want to isolate the square root on the left. So you want to get that square root all by itself on the left. Step number 2 is you square both sides. So we're going to be squaring both sides. Step number 3 is you solve. And step number 4 is you check all answers in the original. So check all your answers in the original equation. So we isolate that root, square it to get rid of it. Now we don't have to have a plus or minus. We only have the plus or minus when we're taking a square root, not when we're squaring. So when we square, we don't have a plus or minus. But a squared is going to undo that square root. Some of these are very easy. Some of them are a little bit more difficult. We're going to start off with a very easy one to look at. And then we'll move on and look at a few more complicated ones. So let's start off with a pretty easy one to work through. How about question, and I'll just pull these from our textbook. How about question 46 on page 165? And we've got x minus the square root of 3x plus 18 equals 0. So this is what we've got, and we need to solve it. So the first thing we have to always do is we want to make sure that the x squared, or whatever square root it is by itself. So we're going to move over that x. Move that x over so that that square root is all by itself. You can square the negative and get rid of it, but I'm just going to divide it out. That way we don't have all these extra negatives. So I'm just going to divide both sides by that negative to get rid of it. It's going to make it a little bit easier, and that way we won't have as many negatives to worry about. Now we should know what to do. So now we have this. We've got the square root isolated by itself. We need to get rid of the square root. So what gets rid of a square root? A square. So I'm going to square both sides. So we're going to now go ahead and square both sides. Now when you square a square root, it's going to go away. So it's going to cancel out. So the square and the square root are gone. And that leaves you with a 3x plus 18. And the right-hand side is an x squared. So that's what we've got here. Now, what are we going to do from here? We should know what to do. If I gave you this equation, what do we normally do? This has a square in it, so we have to set this equal now to what? 0. And factor it. These should factor. You should not have to use the quadratic formula. So move that 3x over and move over the 18 as well. Shouldn't have any trouble factoring. First times the last is a negative 18. And what do we know about the signs? Are they the same or are they different? These are going to be different, aren't they? And sign in the middle is negative. So we've got a negative and we've got a positive. And what two numbers are going to work here? We need that negative 3. And they came from the 18. So what can I use here? I can use a 6 and a what? Yep, 6 and 3. So we need a minus 6 and a positive 3. We don't have to do grouping because there's a 1 here, right? There's no number in front, so there's actually 1. So we can jump straight to our factors. And that's going to be x minus 6. X plus 3 equals 0. And now we've got x minus 6 equals 0. So move that 6 over. So that's x equals 6. And the other one is x plus 3 equals 0. Move that 3 over. And we now have x equals a what? X equals a negative 3. Okay. So, are we done yet? No, because what's our procedure say to do? Let's go back and look. We've got it factored, right? And we solved it. What's our step-by-step procedure say to do? Isolate the root. We did that. Squared both sides. We did that. Solved it. We did that. What do we now have to do for our last step? Check all the numbers back in the original equation. So we're going to check each of these back in the original. So we're going to check them in this. Okay, so check them back in the original. So let's start off with the first one. X equals 6. You have to plug it back in, see if they match up, see if the sides are equal. So we're going to plug in that 6. So that's going to be, when I plug it in, 6 minus the square root of 3 times 6 plus 18. And that should equal 0. Let's see if it does. Okay, so 3 times 6 is 18. 18 plus 18 gives you a 36. And what do we know about the square root of 36? What's the square root of 36? 6. So now we've got 6 minus 6. And 6 minus 6 is 0. 0 equals 0. So it works. So we know that x equals 6 does in fact check out. A lot of times one of them will work and one of them won't. They might both work, or it might be that neither one of them work. So you always have to go back and check them in the original. So now we're going to plug in the negative 3. So we're now going to check the negative 3. And let's plug in that negative 3 and see what we get. When I plug it in, we get minus 3 minus the square root of 3 times a minus 3 plus 18, and that should equal 0. Watch your signs because this one is not going to work. 3 times a minus 3, that's a minus 9. Minus 9 plus 18 is 9. So always be careful with your signs. Square root of 9 is 3. Now that negative is going to come down. Minus 3 minus 3, well that's a minus 6. And does minus 6 equal 0? No. So what do we know? We now know that x equals negative 3 doesn't work. So what is the only answer that we have now? The only answer that we have is x equals now that 6. I want to show you how to solve one more type of equation real quick here. The next one I'm going to give you are pretty easy to work through and solve. We're going to be learning how to clear out these exponents. Work here. So these we're going to have to clear out our exponents. And this is going to be very, very similar to question 15 in your homework. So let's see if we can't work this one out. This will be the last one that we're going to work through. I need to get rid of my fractions. Now, the fractions are a power. How would you clear out the fractions here? Well, what do we have from our denominators? We have a 2 and we have a what? 4. So we want to clear out our denominators. So let's take both sides to the 4th power. This is actually a very easy question to work through. And I'm going to go ahead and pass out the sign-in sheet. This will be the last one that we work through. And then we'll talk about what questions you can work out from your homework. Yeah, I use the 4 because I have a half and I have a 1/4. So these have a least common denominator, right, of 2 and 4, which is a 4, right? So I'm going to use a 4 because that 4 is going to clear out my fractions here. So think about the powers as just like any other fraction. We need to get rid of them, so this is how we're going to clear them out. Now, where we have to be careful is with that 6. So we're going to work this one out. This will clear out our fractions because what's 4 times a half? 4 times a half, that leaves you with a 2. So that's going to come out to be an x squared there. Now, we do have to be careful with the 6 because that is 6 raised to the 4th power. Okay, 6 raised to the 4th power, either write it out or use your calculator. If you want to use your calculator, maybe use that caret key. So 6 caret 4, what does that come out to be? That comes out to be 1269. Okay, or sorry, 96. So 1296 there. And what happens with that 4 and that 4? Well, they do what? Cancel out. 4 and that 4 cancel out. That leaves you then with a single x. Now, we can solve this, and this is very easy to solve. We're going to get 2 solutions, and we're not going to have to check them. The only ones that you have to check are the square roots. How would we handle this equation? We would go ahead and set this equal now to what? 0. And then we can factor, and we'll be done. There's not much to it. So go ahead and move that 1296x over. And now we've got x squared minus 1296x, and that equals 0. So what can I factor out? I want to solve this. What can I factor out? X can come out, okay? And that leaves you then with an x times x minus 1296 equals 0. So what are my 2 solutions here? One of them is x equals 0, because that came from this piece. What's my other one? X minus 1296 equals 0. So x equals, moving it over, a positive 1296. And that's it. Okay, so all you have to do is clear out the powers, move it over, set to 0, factor that x out, and finish it from there. So let's now talk about our homework. No, you don't have to check these. The only ones you have to check are those fractions with the domain and the square roots. So square roots you've got to check. Fractional powers you do not. So what's going to be our homework? Well, your homework is, if you haven't done so, you'll want to finish 1.5. So if you haven't finished it all, you'll want to finish out 1.5. And if you get that finished on Tuesday, I'll collect it. If you need some extra time, you can have a little bit of extra time, but you really want to start working on 1.5. Now, 1.6, we cannot do them all, but we can do a lot of them. So 1.6, here's the ones that we can do. For 1.6, you should be able to do 1 through 7, We can't do 8 and 9 yet, but you can do 1 through 7, and you can do 10 through 12 and 15. We'll finish up 1-6 next class period. 1-6 is just a longer section to cover. So please make sure that you sign the sign-in sheet. If you've got any old homework, make sure I get that. Okay. I'll get that written. Did you turn in your practice exam yet? Okay, you might look and see. I've got your homework graded too, so let me get that, and I'll pass that out real quick here. So if you want to pick up your old homework, I've got it over here. And you can look at Canvas. If you did turn in your practice exam, turn in next time. I'll give you full credit. Okay? Okay. All right. Thank you very much. And graded homework is over there if you have any. And if you haven't completed your exam, find a time to work with me to get that done. But I think everyone in here has done that. So everyone here, I think, believe has finished that exam. Graded homework is over there. I will see everyone then on Tuesday.